everyone. Today we are going to see about the overlap add method. So here the problem is find the output y of n of a filter whose impulse response h of n is equal to 1, 1, 1 and the input sequence x of n is equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1 using overlap save add method. Okay, we are using this overlap add method. So the solution is, first step, you need to find the length of y of n. So let the length of x of n is the input sequence. So here they have given to be 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1. So totally the length of the sequence is 10. So you'll be having 10 numbers. So you have to put L is equal to 10. Now let the length of h of n. So h of n is 1, 1, 1. So the length is 3. So m is equal to 3. Now the length of y of n is represented by n, whose formula is L plus m minus 1. That is 10 plus 3 minus 1, which is 12. So the length of y of n is equal to capital N is equal to 12. Now you need to find the length of h1 of n. That is the new impulse response. So let the length of new h of n is equal to m1. That is new h of n is nothing but h1 of n and its length is m1. So h of 1, that is h1 of n is written as h of n, m minus 1 zeros. So already in the given problem, h of n is given as 1, 1, 1, your m value is 3. So 3 minus 1 zeros you have to add. So 3 minus 1 zeros means 2 zeros. So at the end of the sequence, you need to add 2 zeros. So h1 of n is equal to 1, 1, 1, 0, 0. Therefore, the length of h1 of n is equal to m1, which is 5. Your step 3. So here the input sequence x of n is of very long duration and h of n is given. So if we want to convolute these two sequences, it takes a longer time, and also the storage is also very difficult. So that's why we are going for this overlap save method and overlap add method. So in this overlap save and add method, what we are going to do is we are breaking the long duration sequence into small blocks. So step 3 is breaking the long duration sequence, that is x of n, into smaller sequences of length m1 is equal to 5. So how we have to do this is first add m minus zeros at the end of each sequence. Okay, so listen, we are breaking x of 1, that is x of n. Okay, the input sequence into x1 of n, x2 of n, etc. But the length of each sequences, that is x1 of n, x2 of n, should be equal to 5. That is m1 length. So x1 of n can be written as L data, m minus 1 zeros. And similarly, x2 of n is equal to L data, m minus 1 0. That is, this m minus 1 0 should be added at the end of each sequence. Okay, so for the given problem, x of n is equal to 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1. The x of 1 of n, that is x1 of n, can be written as, see, listen, here I have taken only the first 3 data because the last data should be m minus 1 zeros. Here m value is 3. So 3 minus 1 zeros is 2 zeros I have to add. But the length of each sequence should be 5. So I have to take I have to take only 3 data from x of n. The remaining 2 data are zeros. Okay, so that is the rule. So here in the x of n, I am having 3, minus 1 and 0. So the first 3 data I have taken from x of n. So x1 of n is equal to 3, minus 1, 0, 2 zeros. Okay, so x1 of n is equal to 3, minus 1, 0, 0, 0. So this is the total length m1 is equal to 5. The next is x2 of n is equal to the next 3 L data and 2 zeros. So what is the next 3 data? So the next three data is 1, 3, 2. Okay, so I have taken 1, 3, 2, comma 2 zeros. 2 zeros means this is m minus 1 zeros. That is 2 zeros I have to add. So x2 of n is equal to 1, comma 3, comma 2, comma 0, comma 0. So the total length is 5. Now, x3 of n is next 3 data, comma 2 zeros. So what is the next 3 data? This is 0, 1, 2. So next 3 data is 0, 1, 2, comma 2 zeros. And x4 of n is equal to next 1 data. So listen, since we are having x of n is equal to 10. So for x4 of n, we'll be having only one data, which is 1. Okay. So I have added this data 1. But the length of each sequence should be 5. So what I have done is I have added 0 for the remaining 4 data. Okay, so that such that x4 of n is also having the length 5. So here I have done x1 of n, x2 of n, x3 of n, and x4 of n I have made, and each sequence's length is of length 5. Now step 4 is you need to find y1 of n, y2 of n, y3 of n, and y4 of n. Now what is y1 of n? y1 of n is equal to x1 of n circular convolution of h1 of n. So this, if n is encircled, then we'll call it as circular convolution. For circular convolution, both the data should be of same length. Now what is x1 of n? Your x1 of n is equal to 3 minus 1, 0, 0, 0. So 3 minus 1, 0, 0, 0. Circular convolution of h1 of n is 1, 1, 1, 1, 0, 0. Now you have to write this in the matrix format. Okay, so here I have written 3 minus 1, 0, 0, 0. So the first column's last element is taken to the second column. Okay, first row's second column. First element. Okay, so now this 3 is written here, and 1 comes here, and 0 comes here, and 0 is written here. And for the third column, what you have to do is the second column's last element is taken as the third column's first element. And the remaining data is written in the downward sides. Okay, so 0, 3, minus 1, 0. Again, this 0 is taken to the fourth column's first element. Okay, now this 0 is come here, and this 0 is written here, 3 is written here, and minus 1 is written here. And at last, minus 1 is taken to the fifth column's first element, and 0 comes here, 0 comes here, and this 0 comes here, and this 3 comes here. So totally we have formed 5 by 5 matrix, circular convolution of 1, 1, 1, 0, 0. So here what you have to do is you have to multiply this row, the first row, and this column. Okay, so the first element, the first row's first element is multiplied by the first column first element, and the first row's second element is multiplied by this second element, and the first row's third element is multiplied by this third element, and first row's fourth element is multiplied by the fourth element, and the first row's fifth element is multiplied by this fifth element. Okay, so here we'll be having 3 into 1 plus 0 into 1 plus 0 into 1 plus 0 into minus 0 into 0 minus 1 into 0. And the second row, see the second row, minus 1 into 1 plus 3 into 1 plus 0 into 1 plus 0 into 0 plus 0 into 0. And for the third row, 0 into 1 minus 1 into 1 plus 3 into 1 plus 0 into 0 plus 0 into 0. And for the fourth row, 0 into 1 plus 0 into 1 minus 1 into 1 plus 3 into 0 plus 0 into 0. And for the fifth row, 0 into 1 plus 0 into 1 plus 0 into 1 minus 1 into 0 plus 3 into 0. So here I have got 3 plus 0 plus 0 plus 0 plus 0 and minus 1 plus 3 plus 0 plus 0 plus 0. And third row, 0 minus 1 plus 3 plus 0 plus 0. And fourth row, 0 plus 0 minus 1 plus 0 plus 0. And fifth row, 0 plus 0 plus 0 plus 0 plus 0. So here I have got 3, 2, 2, minus 1, 0. So y1 of n is equal to 3, 2, 2, minus 1, 0. So similarly, you need to find y2 of n. So y2 of n is equal to x2 of n, circular convolution of h1 of n. x2 of n is 1, 3, 2, 0, 0, circular convolution of 1, 1, 1, 0, 0. So here I have written 1, 3, 2, 0, 0. So this last element is taken to the second column's first element. So 0. So 1 comes here, 3, 2, 0. Again, this 0 is taken to the third column's first element. So at the next one, we have to write the 0 here. 1, 3, 2. Again, this 2 is taken to the next column's first element. So 0 comes here, 0, 1, 3. And this 3 is taken to the fifth column's first element. So this 2 comes here, 0, 0, 1. Circular convolution of 1, 1, 1, 0, 0. Now you have to multiply this row by column. See, listen, here the fourth and fifth element are 0 and anything into 0 is 0. Here I have not taken the fourth and fifth element. So the first 3 elements are multiplied by this first 3 elements. So 1 into 1 plus 0 into 1 plus 0 into 1. Second row is 3 into 1 plus 1 into 1 plus 0 into 1. Third row is 2 into 1 plus 3 into 1 plus 1 into 1. And fourth row is 0 into 1 plus 2 into 1 plus 3 into 1. And fifth row is 0 into 1 plus 0 into 1 plus 2 into 1. So I have got 1, 4, 6, 5, 2. So y2 of n is equal to 1, 4, 6, 5, 2. Now what is y3 of n? y3 of n is equal to x3 of n, circular convolution of h1 of n. x3 of n's value is 0, 1, 2, 0, 0. Circular convolution of 1, 1, 1, 0, 0. So here again you have to write this into 5 by 5 matrix. So 0, 1, 2, 0, 0. So this 0 is taken here. So 0, 1, 2, 0. The next one, 0 goes here. Again 0, 0, 1, 2. Again this 2 is taken to the next column's first element. So write 0, 0, 0, 1. And this 1 is taken to the next column's first element. So 2, 0, 0, 0. So circular convolution of 1, 1, 1, 0, 0. Now multiply this row and by column. So 0 into 1 plus 0 into 1 plus 0 into 1. Second row 1 into 1 plus 0 into 1 plus 0 into 1. Third row 2 into 1 plus 1 into 1 plus 0 into 1. And fourth row 0 into 1 plus 2 into 1 plus 1 into 1. Okay, and fifth row 0 into 1 plus 0 into 1 plus 2 into 1. So I have got 0, 1, 3, 3, 2. So y3 of n is equal to 0, 1, 3, 2, 2. And y4 of n. Now y4 of n is equal to x4 of n, circular convolution of h1 of n. That is 1, 0, 0, 0, 0, circular convolution of 1, 1, 1, 0, 0. Now write this in the 5 by 5 matrix. So 1, 0, 0, 0, 0. So this 0 is taken here. So 1 comes here. So 0, 0, 0. Again, this 0 is taken here. So write this 0, write this 1, 0, 0. Again, this 0 is taken here. So 0, 0, 1, 0. Again, this 0 is taken here. So 0, 0, 0, 1. Circular convolution of 1, 1, 1, 0, 0. Now multiply the row by column. So I'll be getting 1 into 1 plus 0 into 1 plus 0 into 1. Second row 0 into 1 plus 1 into 1 plus 0 into 1. Third row 0 into 1 plus 0 into 1 plus 1 into 1. Fourth row 0 into 1 plus 0 into 1 plus 0 into 1. And fifth row 0 into 1 plus 0 into 1 plus 0 into 1. So I'll be getting 1, 1, 1, 0, 0. So y4 of n is equal to 1, 1, 1, 0, 0. The step 5 is find y of n. So here we are overlapping and add. That's why it is called overlap add method. So how to overlap? So overlap the last m minus 1 values of the first sequence with the first m minus values of the second sequence. So, and continue the same for the remaining sequence. Okay, so here, listen, y1 of n is equal to 3, 2, 2, minus 1, 0. So here the last m minus values are 2, that is m minus 1 values means 3 minus 1, which is 2 values. Okay, So the last two values are minus 1 and 0. Now what we are going to do is, while we write this y2 of n, write like this. Okay, that is, this two values should be overlapped with the next output y2 of n sequence. So write like this. So y2 of n should be 14652. So this is the first m minus 1 value. So here for y1 of n, this is the last m minus 1 value. So this last m minus 1 value should be overlapped with the first m minus 1 values of the next sequence. So that's why I have written. And here for the y2 of n, this is the last m minus 1 values. That is 5 and 2 are the last m minus 1 value of y2 of n. And the next sequence m minus 1 values are 0 and 1. So the last m minus 1 values of y2 of n should be overlapped with the first m minus 1 values of y3 of n. And similarly, the last m minus 1, the last two values of y3 of n is overlapped with the first two values of y4 of n. So likewise, you have to add, and that is, you have to write like this. And what you have to do is, the last m minus 1 values of first sequence are added with the first m minus 1 values. So that's why I have put the plus symbol. Okay, now you have to write the output like this. The output sequence y of n is equal to 3, 2, 2, minus 1 is added with 1. So minus 1 plus 1 is 0. So that's why I have written 0. And 0 plus 4 will give you 4, 6, write it as it is. And the last two values of y2 of n should be added with the first two values of y3 of n. So add 5 plus 0, which is 5, and 2 plus 1, the value is 3. And write this 3 as it is. And the last two values of y3 of n should be added with the first two values of y1 of n. So 3 plus 1, 4. Again 2 plus 1, 3 and 1. So I am discarding these two values, these two zeros. Why? Because the length of y of n should be 12. So already I have got 12 and 0. Since 0 has no values, you can leave it also. Okay. See here, y of n is equal to 1, 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. So totally I have got 12. The length of the sequence is 12. So which we have this the same answer we have got in overlap save method also. So for the long duration sequence, you can go for either overlap save method or overlap add method. Thank you.